Hello students, welcome back to ASHISH single hashtag maths. Last time we have done the first exercise of chapter 1, that is real numbers. Now today, in continuation of that, we are going to study fundamental theorem of arithmetic. The fundamental theorem of arithmetic states that every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. I repeat, every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. That means that suppose we have 6. The prime factorization of 6 is 2 into 3. So we can have 2 into 3 or 3 into 2. The order can change, but the numbers will not change. So dear students, today we are going to start with exercise 1.2, which basically deals with the prime factorization and the fundamental theorem of arithmetic. Now see the first question. Express each number as a product of prime factors. Each number as a product of prime factors. So question number 1, first part, 140. We start factorization of 140, so we get 2 into 70, again 2 into 35, again 5 into 7. So 140 can be written as 2 square into 5 into 7. Second part, 156. We start factorization 2 into 78, 2 into 39, 3 into 13. So the prime factorization of 156 is 2 square into 3 into 13. Now moving ahead, third part, 3, 8, 2, 5. We start factorizing with 5, so it will go 765. Now again we divide by 5, so we will get 153. Again we'll try dividing 153, it will be divisible by 3, so we get 51. Again by 3 and we get 17. So 3825 has got the factors 5 square into 3 square into 17. 5 square into 3 square into 17. Now taking up the fourth part, 5005. We divide by 5, we get 1001. Again we divide by 7, we get 143. Again we divide by 11 and we get 13. So the prime factorization of 5005 is 5 into 7 into 11 into 13. So this question deals with the prime factorization of the numbers. Now moving on to question number 2. Find the LCM and the HCF of the pair of integers and verify that LCM into HCF is equal to product of two numbers. So we have to find the LCM and HCF of these given parts. So students, moving on to the first part, 26 and 91. We find the prime factors of 26, which will be 2 into 13. Then prime factors of 91, which will be 7 into 13. As you all know, HCF are the factors which are common. So the common factor is 13. How do you get LCM? The one which is common, we write that, and the remaining factors, like after taking out 13, we are left with 2 and 7. So LCM will be 13 into 2 into 7, which gives you 182. Now, about the verification you can do LCM into HCF is equal to the product of the two numbers. That should come out to be true. Second part is 510 and 92. We find the factors of 510, which will be 2 into 5 into 3 into 17. Factors of 92, 2 into 2 into 23. We can see here the common factor is only 2. So the HCF is 2 and the LCM is 2 into the remaining factors 5 into 3 into 17 into 2 into 23, which gives you 23460. So the LCM of 510 and 92 is 23460. Now students, moving on to the third part, which is 336 and 54. The factors of 336 are 2 into 2 into 2 into 2 into 3 into 7, and the factors of 54 are 2 into 3 into 3 into 3. So what will be the HCF? 2 is common and one of the 3's is common. So 2 into 3, which gives you 6. What about the LCM? First of all, we write 2 into 3 and the remaining factors 2, 2, 2 into 7 into 3 and 3. When you multiply this, you get 3024. So this is the way we find out the LCM and HCF and verify. So verification part, you can do it yourself. Now students, moving on to question number 3. Find the LCM and HCF of the following integers by applying the prime factorization method. Now there are 3 numbers, 12, 15, 21 and so on. So let us take question number 3, first part, 12, 15, 21. Let's find out the prime factors of these numbers. 12 will have 2 into 2 into 3, 15 will have 3 into 5, and this is 3 into 7. We can clearly see HCF. What is common in 3 of them? 3 is common, so 3 is the HCF. What is the LCM? 3 into, now the remaining factors, 2 into 2 into 5 into 7. Now you have to multiply all this and you get 420. So the LCM of these 3 numbers is 420. Moving on to the second part, 17, 23 and 29. 17, 23, 29. There are no factors because they are all prime numbers. So the HCF will be 1 and the LCM will be the product of 3 of them, 17 into 23 into 29, and which gives you 11339. The third part students, 8, 9 and 25. Let us find out the prime factors. This is 2 into 2 into 2, this is 3 into 3 and this is 5 into 5. We can see that there is no common factor, so the HCF is 1 and LCM will be, since there are no common factors, we need to multiply all of them, 8 into 9 into 25, which gives you 1800. So whenever you don't have any common factor, in that case your LCM will be the product of 3 numbers. Now moving on to question number 4. Given that HCF of 306 and 657 is equal to 9, find the LCM of 306 and 657. Students, we have to use the concept LCM into HCF is equal to product of two numbers. We have to find LCM. So LCM will be 306 multiplied with 657 upon 9. With 9, if I cancel this term, it will go 73. So this will be 306 into 73, which gives me 22338. 22338. So that is the LCM of these two numbers. Now we move on to question 5. It's a very important question. Check whether 6 raised to the power n can end with the digit 0 for any natural number n. Basically, we know that any number will end with the digit 0 if it has got 2 and 5 as factors. 2 into 5 makes it 10. Now here, before writing the proof, I will explain you 6 has got factors 2 and 3. Whatever may be the value of n, the factors will be in terms of multiples of 2's and 3's only, so we cannot get 5 over here. Now how do we write it? If the number 6 raised to the power n for any n were to end with the digit 0, then it would be divisible by 5, because 2 is already there, so it will be divisible by 5. That is the prime factorization of 6 raised to the power n would contain the prime 5. So prime factorization should have 5 as one of the factors. This is not possible, as 6 raised to the power n is 2 into 3 raised to the power n. So the only primes in the factorization of 6 raised to the power n are 2 and 3. Hence, the uniqueness of the fundamental theorem of arithmetic, guarantees that there were no primes in the factorization of 6 raised to the power n other than 2 and 3. So there is no natural number n for which 6 raised to the power n would end with the digit 0. So you need to remember this, that this is all because of the uniqueness of the fundamental theorem of arithmetic. Question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Students, in question number 6, we can take 13 common. When you take 13 common, so you have 7 into 11 into 1 plus 1. So as there are two factors, so it is composite number. It is a 1 mark question. You have to just write as it has got 2 factors, so it is a composite number. Same the second part, take 5 common. So you will be left with 7 into 6 into 4 into 3 into 2 into 1 plus 1. Again, there are 2 factors, 5 and this one, so it is also composite number. Now, last question of this exercise, question number 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Whenever you have to find this kind of question, you have to find out the HCF of LCM of 12 and 18. So 12 has got factors 2 into 2 into 3. 18 has got factors. So the LCM will be 2 is common, 3 is common, so 2 into 3 into 6. So 6 6 the 36. So after 36 minutes, they will meet again. So students, I hope you have understood this exercise, that how do we do these kind of questions. Now, these are the practice questions based on exercise 1.1 and 1.2. I'll read out. Question 1. What is the HCF of the smallest prime number and the smallest composite number? Second question. Given that LCM of 91 and 26 is 182, find the HCF of 91 and 26. Question number 3. Find HCF and LCM of 90 and 144 by prime factorization method. Question 4. Show that any positive integer is of the form 4q plus 1 or 4q plus 3, where q is some integer. Fifth question for the practice, using Euclid's division algorithm, find the HCF of 1656 and 4025. So try this question. They are based on exercise 1 and 2, and keep revising this concept. In the next episode, I will give you the answers of these 5 questions, and then we will continue the next exercise. So keep working hard, students. Hard work is the key to success. Thank you for being there and listening patiently.